In this video we're going to look at how to construct Venn diagrams and how to work out probabilities using Venn diagrams. So we're given some information here, and this is using set notation. So the first one here we read is the probability of A intersection B, and that means the probability of both event A and B happening at the same time, and that's 0.3. Then we've got the probability of event A happening is 0.5, and the probability of event B not happening, which is indicated by the dash, is 0.3. So I've got two different events here, so I'm going to construct my Venn diagram here. So I have a box, and everything contained within this box must have a probability of 1. And then within that I have two different events, so I'm going to use one ring for event A and another ring for event B. So what do I know? Well, I know the event of both of these happening, so A and B. I know that probability is 0.3, so this region here is in the A ring and the B ring, so that represents both happening. Now the probability of event A happening is 0.5, and 0.3 of that is where B also happens, which means there must be a 0.2 chance that event A happens but not event B. Now the probability that event B does not happen is 0.3, so that's everything that's not inside the B ring, so that must be 0.3. So I've already got the section here which is in A but not B is 0.2, so the remaining 0.1 from that must be what is the chance of neither event happening. So I've only got one more region to complete now, and these three add up to 0.6, so 0.4 must be that missing probability. And now I have a completed Venn diagram, I can answer some questions about it. So just try and keep it in the picture. So find the probability of event B happening. So the probability of event B happening is going to be 0.3 plus 0.4, which is 0.7, and that's just adding these two, which is everything inside the B ring. So find now the probability of A union B. So this means that A or B can happen. This should be a little bit more U-like than it looks there. So A union B, so that's all three of these, because all three of those are in either A or B, or both. So 0.2 plus 0.3 plus 0.4, which is 0.9. So now I've got to find the probability of A union not B. So this is things that are either in A or they're not in B. So I've got four regions to consider. So this outside region, does that meet either of those criteria? Yes, because that's not in B. So I need that probability. What about this one? Well, this is in A and is not in B, so that actually meets both of these criteria, so I need that one. About this middle bit, well, that is in A, so that meets this part of the criteria, so yeah, I need that probability. And then this one, well, this is not in A, so it doesn't meet the first part of this criteria, and it is in B, which means it doesn't meet the second part of the criteria either. So these are the only three probabilities I need, which add up to 0.6. So final question here, so find the probability that it's not in A, intersection not in B. So this is looking at what is not in A, but is also not in B. So if we look at the different regions, so this outside region is neither in A or B, so I've got that probability. Now this one is in A, so I have to discount that. This one is in A and B, so I discount it, and this one is in B, so I discount it. So it's just this probability is 0.1. Now one way of looking at the differences between, say, these two is this one when you've got the union, either of these two criteria met, and then you include that region. Whereas this one, it has to be both of them. So although all the regions apart from one include one of these, there's only one of them that includes both of them, so that is the 0.1.